Okay, this video is to help you understand another operation that you can do with functions, and that operation is called composition. It's an operation you can't do with normal numbers because you can't plug a normal number into another number, but you can plug a function into another function. So you could form a function h of x by taking g of x and inserting it inside of f of x, or taking f composed on g of x. Another way to write that function, instead of saying f parentheses g of x parentheses, is to say f open circle. Note it's not filled in. If it was filled in, that'd be multiplied. We're doing composition. That's different. F composed on, or open circle g of x, saying that they're both functions of x, but what we're doing is plugging one function g inside of function f. Each of the outputs from g essentially becomes the input for f. The domain, though we'll come back to that, essentially is the domain of the inside function as well as the domain of the entire function in order to determine the domain of the function as a whole. To find the following in their domains, basically the idea is, again, we're taking f composed on g. So what I'm going to do is, instead of f of x, everywhere there used to be an x, I'm going to plug in g of x. So I'm going to say f composed on 2x minus 1. So anywhere that there used to be an x inside of f of x here, so anywhere right here that there used to be an x, I'm going to plug in 2x minus 1. So 3 times the quantity to the negative 1, and I'm going to insert that 2x minus 1 in its place. Again, f being this outside sort of blue function, so f containing the 3 and a variable raised to the negative 1, and I'm just plugging in that 2x minus 1 inside. So then I can simplify that. Now notice that entire function is raised to the negative 1, so I'm going to say 3 over 2x minus 1, because that whole thing flips to the bottom of the fraction, and since there's no simplifying to be done, that would be your final answer. Again, to find the domain of that function, we're going to consider the inside function first. Well, the domain of g of x is just that x can be any of the real numbers. Right? It can be anything real. We're multiplying by 2, we're subtracting 1. It can be any real number. And then when we look at the final function, well, now I can't divide by 0. Notice we made this into a quotient. So I need to make sure that 2x minus 1 doesn't equal 0. So let's do a little side work here. 2x minus 1 would only equal 0 if I add 1 to the other side and divide by 2 if x were a half. So x can be all real numbers as long as x does not equal 1/2. That would be a good domain for the function. So let's do the same thing with g composed on f of x. Go ahead and take g of x being our outside function, and we're going to insert again this blue function here, f of x being equal to 3x to the negative 1. So g composed on 3x to the negative 1. Well, g was 2 times the quantity minus 1 of 3x to the negative 1. So very simply, multiply by 2 is 6x to the negative 1 minus 1, or 6 divided by x minus 1. And that would be a good function. Again, to consider the domain, well, now the inside function is f of x. And because f of x meant that x was on the bottom, that means that x could not have been equal to 0, was its domain. So if I can't plug 0 into my original function, notice I also can't plug 0 into my final function because 6 is being divided by x. I can get all real numbers as long as x does not equal 0 for that function. And finally, f composed on itself. Well, we're going to take the outside function. We're going to plug in f of x on the inside. Again, that's this part. So I'm going to take 3 composed on something to the negative 1, inserting my 3x to the negative 1 from the inside here. 3x to the negative 1 goes right down in here in place of what used to be x in f of x. This now becomes, well, if I distribute that negative, 3 times 3 to the negative 1, and remember, power to a power we multiply, Negative 1 times negative 1 is positive 1. Well, 3 times 1/3, essentially, right? 3 to the negative 1 is 1/3. So 3 times a third disappears, and we basically just get x. So it looks like its domain should be all real numbers, but don't forget, we need to consider that inside function as well. Since f of x was inside, the domain here was that x could not be equal to 0, right? It was all real numbers, such that we weren't equal to 0. Well, the same thing goes at the bottom then. All real numbers except 0. Now, let's take a look at a few more examples here on the next page. What if we started off with a number? And this will really help you understand composition at its basic. If we were just doing a division problem instead of composition, divided by g of 1 is basically saying find f of 1 divided by g of 1. So if I plugged 1 into f of x, f of 1, right, is equal to 3 times 1 minus 4, or negative 1. So I'm going to take negative 1 divided by, well, g of 1, which is 1 squared minus 1, which comes out to 0. So that's divided by 0, and basically you get undefined. Well, composition's a little bit different. I can't just do them both separately and then divide. Composition says, well, I need to find g of 2 first. So I can take f composed on g of 2. Well, g of 2 is equal to 2 squared minus 1, or 4 minus 1 is 3. So I'm going to take f of 3. So even though it started me off with the 2, I need to do that inside function. Its output becomes the input for f. And f of 3 is just 3 times 3 is 9 minus 4. So that makes 9 minus 4 is 5. Because f of 3, when I plugged 3 in for x, was equal to 5. Okay? Or it was 3 times 3 minus 4. Let's go ahead and do f composed on g of 0. Same thing goes. So I'm going to find f composed on g of 0. So f composed on, well, g of 0 is 0 squared minus 1. 0 squared minus 1 is negative 1. So what we really want to find is just f of negative 1. The output from g of 0 becomes the input for our next function. F of negative 1 is 3 times negative 1 minus 4, or negative 3 minus 4 is negative 7. Go ahead and try this function at the bottom. Do the top, do the bottom, and then do the division and see what you get. I'll pause the video now and have the answer on the screen for you when I'm done. Okay, working with the numbers at the bottom. Again, the top statement is saying f composed on g of negative 3. So I went ahead and found g of negative 3 was 8. On the bottom, we're just adding. So again, we could do these separately. F of 3 plus g of 3 essentially becomes 5 plus 8. Note all the work down here at the lower left. So f of 8 is now what I need to find on the top, right? The output from that inside function. Whereas on the bottom, I can literally just add my two numbers together. I'm just going to do the operation afterwards. So 5 plus 8 became 13. F of 8 down here in blue is 20, and 20 divided by 13 is my final answer. Now it's a little bit trickier when we talk about these functions with just variables inside them. Again, now we're not finding the numbers, we're finding a new function. So f composed on g is saying take f of x and plug in g of x. I'm going to insert g of x, so I'm just going to put this right here, inside of here. So let's do g of x in green here. So I'm going to take that outside function, f composed on, and I'm going to write in g of x, x squared minus 1. Which means I take f of x, 3 times x minus 4. And again, what used to be an x in my equation up here, my function, now becomes g of x. So I'm going to insert x squared minus 1 in place of that x, 3 times the quantity g of x minus 4. Now you just have to clean it up a little bit. it's 3x squared minus 3 minus 4, so 3x squared minus 7 is my final statement. Now, it didn't ask for domain, but let's go ahead and do that anyway. Let's find the domain. So taking a look, again, two spots. First, we need to look at g of x on the inside. Well, domain of g of x is that x can be anything. Squaring a number doesn't stop us. Subtracting won't stop us. So again, all real numbers work. And again, same thing for the final statement. Squaring, multiplying, subtracting. Nothing goes wrong when you do those steps. G composed on h of x, on the other hand, well, I'm going to plug h of x, again, inside of g of x here. So I'm going to say g of square root of x. And in that case, g was x squared. So I'm going to do a quantity squared minus 1. Taking out x from g of x here, I'm plugging in, right, that square root in for x there. So square root of x goes here. Well, the square root of x squared is just x minus 1, and there would be my final statement. Now I got to be careful there though, because although subtraction never has an issue, I need to look at my inside function. The domain of h of x when we started, square roots, remember, x would need to be greater than or equal to 0. I can't take the square root of a negative number and get a real answer back. Which means at the beginning of this problem, or even in this statement, I can't take that square root before I square it and subtract unless x was greater than or equal to 0. Figure out the domain of the inside function, combine that with the domain of your final answer, and the overall restricted domain will be your final domain. Lastly, just a quick example for you where you would see composition in the real world. We do actually see this even though we haven't learned about it before. A computer catalog offers computer savings of 15% off the retail price. At the end of the month, you can also earn a discount coupon of just $50 off of a computer. So, which one would benefit you more, taking the discount first or taking the savings first? Well, let's think about this. If the savings, S of x, is really equal to 15% off the retail price. So I'm going to take my retail price, right, times 15%, and then I'm going to subtract that from, or I'm going to add it to, here, let's rewrite here. I'm going to take my original price then minus that amount, or essentially what becomes 0.85. I'm going to pay 85% of the original. The discount price, on the other hand, the discount coupon, is really just saying take any computer and subtract $50. Well, which one comes up cheaper for a $1,000 computer? S composed on D of 1,000 or D composed on S of 1,000? Well, let's do some math here real quick. D of 1,000, we're plugging 1,000 in here, is essentially $950. Then I need to take 85% of that, or if I figure that out very quickly here, or essentially take 0.85 times 950, right? Plugging my 950 back into the S here, you get $807.50. Again, you can check that number on your calculator. Well, how about we do it the other way around? What about if I took 85% first? So first I'm going to plug it into my S function. So 85% of 1,000 is 850. Now let's plug that into D of x. So now let's take our 850 and subtract the $50 second. Well, notice this way we only have to take, or only have to pay $800. So which one's more advantageous? Well, if you're the store, you're going to want to make more money. So they're going to take their $50 off, then give you your 15% discount. However, as the buyer, I would much prefer they take 15% off 1,000, then give me a full $50 off. So you can see where composition of functions can matter whether or not you do the inside function or the outside function first. I hope that helps you with composition. Have a great day.